Present now. Uh, this one. Wait. Stop presenting. Share. Yes. Are you able to see the background? All of you?
Yes, sir.
Okay. Very nice. So, in today's class, let's discuss the estimation of air gap length. So, we definitely know there is a distance between the stator and the rotor, and they are not electrically connected in the machine. So, there is a small amount of air gap between the machine. So, in today's class, we will take up the discussion how to calculate and the estimation of air gap length in the synchronous machine. So we saw the magnetizing current and the relation between the air gap length in case of the induction machine. Some of you also give the flip class. So let's start today's class. So discuss the estimation estimation of air gap length. Discuss the estimation of air gap length in in synchronous machine. So the factor in case of the synchronous machine that is responsible for determining the air gap length, it again depends upon the field current. So here yesterday we studied about this SCR, that is nothing but the short circuit ratio. So I also showed you this short circuit ratio, how it was relevant. You can also write it like Z per unit because it was V open circuit voltage by I short circuit current at rated IF, and this also at rated IF. So the field current was same in both the cases. So now like no load MMF per pole is equal to what? See this MMF. So in case of the air gap, how do you discuss the air gap? So here I will write down, see, my no load MMF, that is my magnetizing, my MMF is this quantity, this no load MMF. So my no load MMF per pole is equal to what? Tell me. Is equal to the product of, is equal to the product of armature MMF. Okay. So what is the armature MMF developed per pole? Armature MMF per pole and the short circuit ratio because see as far as my mmf is concerned, my mmf is equal to your number of turns into your current. Okay, so that is no load. At no load, every machine has this particular value, this Z per unit, it has a particular value. So this current value also you can express in terms of the voltage and current. Okay, so we can see my voltage value, for example, is equal to V open circuit, if I want to write down, is equal to ISC into this Z per unit value. So more or less you see this is my short circuit ratio. Essentially my Z per unit over here is my short circuit ratio. So when I have to calculate my MMF, okay, so I have my MMF in terms of short circuit ratio. So that means at load, so at no load, the MMF would be the rated value. So the at no load, because we are not connecting any load. So at no load, my MMF, whatever MMF I'm developing, for example, for a 60-degree polar axis, if I'm developing, usually I told you in the last class also in the induction machine why we do for this pole, because it's a polar axis. So we will write this like MMF at no load ATA into my short circuit ratio. So this is the effect of the mmf at no load and the short circuit ratio, and the value of armature mmf per pole, which we also derived previously. I showed you the equation. You can go back to the drive. Okay, you can check this equation. So the value of armature mmf. Okay, this is the value of mmf armature mmf per pole. So if you write the value of armature mmf per pole, that is ATA, so it happened to be 2.7 times I phase T phase kW. Okay, this is the winding factor divided by P. So this formula we have already derived. So this 2.7 T phase K phase. So this was my no load mmf. See, the value of no load mmf can be estimated. How can? By assuming a suitable value for short circuit ratio. So the mmf can be estimated by assuming a, assuming a suitable value of SCR. So we will assume a suitable value. What does that suitable value mean? So the suitable value as such, it means, see, what we require is the value of this mmf required for driving the fluxes across the air gap is approximately 80% of the no load mmf. Okay, in case of synchronous machine. So in case of that, when we were calculating the value of the entering current also, bar current also, you have noticed how we came to the expression. We calculated for the stator side and then equated the stator side flux in terms of rotor side to 85%. So here, let's suppose the mmf required. So the mmf required for driving the flux, the driving the flux across the air gap, across the air gap. So this is the mmf required for driving the flux across the air gap is 80%. Suppose is 80% of the no load mmf, of the no load mmf. So this is a suitable assumption, no load and mmf. This assumption enables us to estimate the air gap length. So with this estimation, this this estimation this estimation leads to calculate calculation of what, of of no load field mmf. So this is the thing. This estimation will help us in calculation of the no load field mmf. So the mmf required for the air gap would be mmf required for air gap would be equal to zero point 0.8, that is 80%, 8 by 100, 0.8 into ampere turn mmf for full load. Okay, so this 80% into 80, you have also seen the statistical calculation similar to the induction machine. This can be also written in terms of this can be also written in terms of, here I'll write down, you have seen 80,000. Okay, 80,000, this is my air gap, flux density of the air gap. Okay, this is my this factor, and this is my length of the air gap, LG. So I have to calculate the LG, where I'll write down where BG is equal to maximum flux density. Okay, this is maximum flux density in the air gap. Okay, and your LG is equal to length of the air gap, length of the air gap. So now you have to calculate the value of LG. So the value of LG, see this value, this. So we just now noticed the value, two values, zero point 0.8 into 80 at full load is equal to 80,000 BG, kg and LG. Now we want to calculate LG. So the value of LG would be equal to 0.880 full load divided by, what happened? What is this? Okay, wait. Some, yeah. Yeah, wait, I'll rub this. Yes, I'll write down. LG would be equal to, so I can write my LG equals to 0.8 AT F naught divided by 80,000, okay, BG kg. In other terms, this can also be written in terms of other factors, okay. So this is the length of the air gap. It can also be written like this, kf, okay, AT full load 80,000, okay, B average, okay, B average and kg, okay. Here it was bg and kg. So when we are writing the term B average, okay, so this B average and kg, instead of that this term 0.8, okay, 0.8 and B average term will be written in terms of kf. So let's see one problem to understand the better concept. So let's do go for one problem so that we will understand, enhance our learning of the subject. So this problem has came in the V2 examination for 6 marks, okay. So this is a VTO question. So most of the times I'm doing VTO questions only, and not mentioning it, but now I decided so that you gain the confidence. So this is again a problem that has appeared in V2 examination. So question is 500 kVA, 500 kVA, 3.3 kV, 3.3 kV, 50 hertz, 50 hertz, 600 rpm, 600 rpm, three phase salient pole, salient pole, three phase salient pole. Alternator has 180 turns per phase, 180 turns per phase. Estimate 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 the length of air gap, which we just now saw calculated. Length of air gap, okay, this we have to estimate. Length of air gap if the average flux density, if the average flux density, if the average flux density is equal to, if the average flux density is equal to 0.575, 0.575 Weber per meter square. So this is one thing, Weber per meter square, okay. This thing, a pole arc to pole pitch ratio, that is L by tau or L by Z ratio. This is pole, okay, this you remember, pole arc to pole pitch, okay, ratio is uh, equal to 0.66 short circuit ratio. This is short circuit, okay, ratio. This is the SCR. Okay, SCR value is given as 1.2. Gap contraction factor, that is your kg. Okay, kg, this is nothing but contraction gap contraction factor. Gap contraction factor is equal to 1.15. Gap contraction factor. Okay, the mmf the mmf required the mmf required for the mmf required for the air gap is 82%. 82% of the no load mmf, and your this kW value is given here. If it is not given, you take it as 0.955. Okay, so this has come in the examination for 10 marks. This is the question in V2 exam only. So if you see, if you leave the last model, now you are doing mistake. Never leave the last model. Okay, if you are leaving all the models, what happens is that we do 2 3 models, and then in the examination we think the last model we will not do. The most easy questions will come from the last model. So in the class, I will always tell, concentrate in the first 15 minutes and the last 10 15 minutes. In between, if you miss also, no problem, because the first and the last part is very important. So similarly, when a question paper sets a question, so what he thinks is that no, no, today he is in a very tough mood, he starts to make tough questions. Then he reaches to the last model, he thought, no, no, I have made it too tough, so he tries to give some simple questions. So that is what the psychology of a human being is. After all, a teacher is also a human being only. So this is how you should prepare. Okay, so like if you are doing an gate examination, some of you will tell ki no, 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 we will do only 50%, rest 50% portion we will leave. So that's a wrong strategy. You study every 100%, you have to study. Some portions you make it very strong, but other portions also you need to study. Syllabus coverage has to be 100%. You never know, from certain portion there would be very simple questions. Because you have not touched that portion, you will not gain that access. Are you getting my point? Afsa, Ratika, Ratika,
Yes,
did you get my point? When you are
yes,
preparing for an examination, how you have to do, so that is also very important. And one more thing, Manohar, are you there? See now,
Yes, sir.
yeah, now this question has come, so immediately you should not hurry to the writing the answer. So first you read the question properly. Okay, so you have to read, check all the ratings, this are in similar or not, that the units are similar, this thing, that thing. First in your mind you have to make up. So if you are doing in a hurry burry, so you will land up in a problem. So the thing is that is asking for the air gap length. Okay, before moving to the air gap length, what are the quantities we will require? So definitely we know the air gap length. We just now saw with the formula also, the air gap length was equal to, just now the formula we saw ki what we need is that we need this zero point 0.8 into, but here he is mentioning the mmf required for the air gap is 82%, so we cannot write zero point 0.8, so it has to be 0.82. Okay, so in the formula we have to write 0.82. Okay, into the so the we need this value. Okay, we need lg value, and we know that this would be equal to 0.82 into ampere turns of full load divided by, okay, 80,000 bg kg. Okay, so we know this because we just now calculated. See, if you go to the last point, this thing 0.8 to 80, okay, 80,000 bg kg. So we need this value. Okay, so we have to occur at this value, but see, bg kg value is given. Okay, bg value is already mentioned there. So bg value is how much? Bg value is given, the estimate the length of average flux 0.575. So you can 0.5, and kg value is given, gap contraction factor. but this is not the BG value. Okay, this is what value given? This is BAV value. So this is not the BG value, sorry, this is BAV value is equal to 0.575. Okay, we want the BG value. So how do we calculate the BG value? BG and BAV have, see, BG would be equal to BG into KF, that is the, this factor would be equal to BAB. Okay, so they have mentioned the KF value is also there. This is the contraction factor, K gap, that is the kg 1.15. so this thing, another thing 0.66 they have mentioned. Okay, so KF value over here, how do you form the KF value? See, the pole arc to pole pitch value is also called, you can take it as a KF value, that is field form factor, that is given here. See here, this is called field form factor. Okay, so this is field form factor, this is given KF, this is pole arc to pole pitch. Okay, pole pitch. Okay, so this is basically pole arc to pole pitch value, so you can take this as this KF value. So this is also given 0.66. so first you need to calculate the BG value, not BAV. so BG value would be 0.575 divided by 0.66, so it will come around 0.87. you just calculate and tell me how much it will come. How much it will come? Around 0.87. Okay, 0.575 divided by 0.66 would be around 0.87. Okay, are you getting it, Ratika? Calculate, tell me. Please calculate it. You have to be present in the class. Okay, yeah, how much you are getting, Manohar?
0.8742, sir.
Bas 0.87, very good. So now the kg value is there. Okay, kg value is there, kg is given over there, it is 1.15. okay, BG you just now calculated, so you require now this value, only this ampere turns. So ampere turns, if you have to calculate, so you know that your ampere turns for armature mmf per pole, so you have to go for the armature mmf per pole. Okay, so here armature, say some problem happens here every now and then. Yes, so armature mmf per pole, armature mmf per pole would be equal to, tell me. See, in the previous session also when I was calculating this, so it was 2.7 I phase T phase kW into P. So armature mmf per pole is what? Is equal to how much? 2.7. This formula we have derived in the induction motor section. 2.7 into I phase, okay, T phase kW by P. So this value you can calculate. Please calculate the value. Number of poles 600 rpm. Okay, so what you require is the number of poles. So calculate the number of poles. See, you can calculate the number of poles. If the number of poles are not mentioned, so you can calculate the number of poles. Okay, 600 rpm. So you can calculate the number of poles. How do you calculate the number of poles? See, yeah, I will not do this problem. So you calculate the number of poles, please. Now I have done so many problems. By now you should be able to do this. So what else is mentioned over there? Yeah. So I'm waiting for you. I'll wait for 2-3 minutes today. So let's see. Chaitra.
Yes, sir.
Calculate the number of poles. Okay. Akansha. Akansha.
Yes, sir.
You also calculate the number of poles. You see how you will calculate the number of poles? Akansha.
Yes, sir.
Yeah. Don't unmute yourself. How you will calculate the number of poles? What you will do in order to calculate the number of poles? See, how you will do is that your synchronous speed is given, so your RPM is given over there. Okay, NS is given 600. Okay, 600 RPM is given. So you can convert that in terms of RPS. That is 600 by 60. That would be 10 RPS. So you have the formula for F, frequency is equal to, okay, or number of poles is equal to 120 F by speed is equal to N is equal to 120 F by P. So from there you can calculate the number of poles. Bhavna, Bhavna. Yeah, by now you should be able to calculate the number of poles because I have already given you the hint also. So, so you calculate. Yeah, it went. Hmm, December. Yeah, it's tomorrow is today. Okay. So you can calculate the number of poles. Yeah, Nilinakshi, you try. See here, it is given 600 RPM. Okay. So if you know your formula NS is equal to 2F by P, calculate it in terms of NS. This N is equal to 600 RPM. So NS is basically N by 60. So this is N by 60 means N is equal to 600. So this is 600, this is 10. This will become, NS will become 10. 10 into 2 into 50 by P. So number of poles would be 100 by 10. How many number of poles? Why you are not doing? What is the problem? Such simple question. Manohar, Ajit Kumar, Ratika,
Yes, sir.
why you are not
10,
doing? Huh?
10, sir.
It is so difficult. Huh? Like I'm asking you some simple thing, and it is like rocket science you are doing, behaving. Very simple things that it's for 10 marks and it's very simple. I thought everybody will be able to do. See, the number of poles will be 10. Okay, you're not paying attention at all. Like in the classrooms, if you go back to the videos in your drive link earlier, okay, no problem, there was some problem issue with the writing and all that thing because I was using that, but now it's very crystal clear. Still you are not doing. See, you have to, like, if you are there in the classroom, although it is online, but you should do. It's not looking good because today you are behaving like this in the classroom. Same will happen in the examination. Yeah, all of a sudden, if they decide to conduct an examination with masks and distance and everything, then I think it would be very difficult for passing also, because elementary things also you are not able to do. It's not looking good at this particular point. So again, see, look at the problem. So the 500 kVA, okay, 3.3 kV, 50 hertz, 600 rpm, three phase cell and pole. Please pay attention. Cell and pole alternator has 180 turns per phase. So he's asking us to calculate the estimate the length of the air gap if the average flux density is 0.575 Weber per meter square, and your pole arc to pole pitch ratio is 0.66, and your short circuit ratio is 1.2, and your gap contraction factor is 1.15. The mmf required for the air gap is 82% of the load mmf. Your kW value is this. So um, let me start the problem. Okay, see, first thing first. So first thing is your ns value. Okay, synchronous speed value would be equal to 600 divided by 60, because this is nothing but n by 60. So that is 10 rps. Okay, so the first thing what you do in a problem is write the given data. Okay, so I'm not writing this time the given data, so you have to write it like, okay, then if you get the value of ns, okay, you know your ns value is equal to 2f by p, this formula. Okay, 2f by p. If you are not remembering this formula, No problem. Most of you remember this formula. N is equal to 120 F by P. Okay, here only you substitute Ns by 60 is equal to 120 F by P. So in terms of Ns, you can write 60 divided by 120. Okay, and this F will remain by P. So this would become 60 goes here. Okay, nothing else. Ns remains here. So 61 are 2 are. So this is yeah, 60. Something wrong has happened. And okay, wait 1 second. Yeah, n is equal to 120 F by P. Yeah, Pn is
So
equal to
NS
120.
into 60.
Huh? Ns in.
NS into 60, sir.
Wait. Wait. Something. Yeah. Yeah. Ns is equal to n by 60. So yeah. So instead of n, you have to write 60 ns. Okay. So this would be 120 f by p. This is 60 ones are. This is twos are. So this is 2 f by p. Okay, correct. So this is from here. So much like you have frustrated me. Even the basics I'm not able to deliver. Okay, no problem. So you get this ns is equal to 2 f by p. So you get the value of p. This would become 10. Okay, this 2 into 50 and number of poles you require. So this would be your number of poles. This is 100 by 10. This is 10. Okay, so now you got this value, and now the current per phase you want to know. Current per phase, I phase. So I phase in terms of if you write the kVA equation, so you have in terms of kVA you have root 3 V phase I phase into 10 power root 3 I phase into 10 power 3. Okay, so I phase would be equal to kVA into 10 power 3 root 3 into E line. Okay, so the thing is that kVA value it's mentioned it's 500 kVA. Okay, so we have 500. See, 10 power 3 I have multiplied. Okay, so usually you will see it is 10 power minus 3. At that time, why it is 10 power minus 3? Because our voltage is in V. So V to kVA we have to do. So we have to multiply it with 10 power minus 3. But here if you see the problem, so it's already there in kVA value. So this is 500 kVA. Okay, so we will write this I phase would be equal to 500. Okay, and 10 power 3 in terms of voltage. Okay, so this is kVA, this in terms of V. Okay, and then we have root 3. Okay, into again we have this root 3, and this is 3.3 kV. So 3.3 kV in terms of 3.3 into 10 power 3. Okay, so we can write this like this: 500 into 10 power 3 root 3 into 3300. So this, if we calculate, no need, this is I was just elaborating, 87.4 amps. So you'll get the value of 87 point, this value will get around 87.4 amps. So now you got the, because when you had to calculate this value here, so because you have to calculate the number of poles you needed, I phase you need, kW value is there, T phase is given there. Okay, T phase value is given 180. So now you can substitute to calculate this value. So you can substitute in the equation to calculate this value. What is our equation over here? The equation over here is armature mmf per pole. This is our armature mmf per pole, this equation. So how I will write this armature mmf per pole? It would be ATA would be equal to 2.7 into I phase. That value we calculated. T phase is given 180 turns into kW as number of poles we saw it was 10. So we'll substitute. We have every each and every value. 2.7 I phase we calculated 87.4. Okay, we have number of turns 180. KWS value is given 0.955. Number of poles is equal to 10. So we substitute it. We get a value of MMF. So this value is 4056. So but what we require is no load MMF. Okay, no load MMF, we what we saw is no load MMF is equal to, hmm, if we see the no load MMF here from the this air gap length calculation, so we saw the value of the armature MMF per pole was this. So no load MMF per pole is equal to the product of armature MMF, that is into the short circuit ratio. So here in the problem, the short circuit ratio is mentioned 1.2. So our no load MMF would be MMF per pole into the short circuit ratio. So our no load MMF we can calculate. No load, no load MMF per pole, no load MMF per pole, that is ATFO. This is no load MMF. This is a symbol. You can write any symbol, no problem. Symbols hardly matter. This is the armature MMF into short circuit ratio. So short circuit ratio was nothing but 1.2. So and this value was 4056. So it will be 4056 into 1.2. That will come around 4868. Okay, this is ampere turns. Okay, so this is now we have every value is there. Okay, so the thing is that we know from the formula directly also we can write down, or else we know our MMF of air gap. Okay, MMF of air gap, MMF of air gap is equal to 80,000. Hmm? Yeah, one to eight. This is 80,000 into BG kg, and this length we require is equal to 0.82% of this MMF. 0.82 of into 80 F naught. So this 0.82 80 F naught, what value we got? This is 4868. So all the values we have. So we need this value. So LG value, BG we calculated. BG value is calculated 0.87. We just saw BG value. The BG value is here 0.87. Okay, 0.87. How it came? 0.575 divided by 0.66. This is the BG into KF was equal to BAV. So BG value we have. Rest other values we have. We can substitute, simple substitution in this, and we get the value of LG. KG value is given. KG value is given 1.15. Okay, KG value is given 1.15. So you can substitute for the length of air gap. If I take this equation on the other side, I'll rewrite it. So if I take this equation, so I can write it like length of air gap, length of length of air gap, that is my LG, would be equal to 0.82 into 4868, 0.8 to 4868, 80,000, 00, okay, into BG kg. So if you substitute it back, you say 0.82 into 4868 divided by 80,000, 80,000 into 0.87, 0.87 into 1.15. So this value of the length of the air gap happens to be around 5 millimeter. If you calculate this value, so it is 5 millimeter. So this was a very simple problem, and I'm not understanding why you people are not able to do this. So do this problem, please. One more problem I'm putting. Did you understand? Any doubts you are having? Yeah, Chaitra, Chaitra.
No,
Yeah,
sir.
no, no, no. Seriously, are you sure you don't have any doubts?
No, sir.
Ratika,
Yes,
Ratika,
sir.
any doubts you are having? Any part like how it came and length of air gap and anything? Any doubts anywhere?
Sir, can you go to the previous page, sir?
Yeah. I'll go to the previous page. Yes. Wait, 1 second. Yeah, please tell me if you have doubts anywhere. You are, yeah. Tell me. Yes. This
Yes,
page?
sir. Another one, sir. One more page.
Yeah.
So here we wrote KVA is equal to root 3 V plus I face into 10 power 3 now, sir.
Huh?
Then I face is equal to KVA into 10 power minus 3 should come now, sir.
No, KVA in the sense means what KVA value? Which KVA value? This KVA is this KVA.
So from that
Five.
equation, no, sir, from that equation we wrote I face equation now, sir.
No, see, basically what happens is there. I'll just explain you here. So your see KVA means KVA of the machine. KVA of machine. Okay. KVA of machine. If you are writing in terms of phase quantity, it would be 3 V phase I phase. Okay, 3 V phase I phase. Okay, 3 V phase I phase. But you are writing in terms of what you're writing in terms of you're writing in terms of line quantity. So there is a 3 V line I line. Okay, so 3 V line I line. This is the KVA of the machine. So if you notice, the V line value is given in terms of um, kV value. Okay, okay. So here, if you just see this thing, so I have written root 3 V line. Okay, V line I line. Why I did into 10 power 3 is because usually we do 10 power minus 3. This value is 500. Already kVA is mentioned over here. 3.3 already kV is mentioned over here. But current, are we calculating in kiloamps? No, we are not calculating. Current cannot be in kiloamps as far as the machine is concerned. So the thing is that here, so when I'm writing this, the root 3, I'm expressing this in terms of volts. Okay, expressing this in terms of amperes. Okay, so this is 500. Okay, 500 kVA is equal to root 3 V line I line into 10 power 3. So if you will notice what I'm doing here in the problem, if you're getting any doubt, see here. When I'm calculating I phase, so I'm writing I phase is equal to, see, 500 kVA. Okay, 500 kVA. So I'm multiplying with 10 power 3 over here. Okay, then root 3 E line I know is 3.3. Okay, 3.3 kVA. So I'm writing this kVA, sorry, kV. I'm writing this kV also in 10 power 3. What I'm trying to do is that I'm trying to, this 500 kVA also, I'm trying to convert this into volt. 500 into 10 power 3 VA. Are you noticing? So this is 500 in 10 power 3. Root 3, 3.3 kV also I'm trying to convert into volt. So when final expression I'm getting 87.4. So this I'm getting in terms of amps. Suppose if I don't convert this, okay, I write this 500. Okay, then this is getting cancelled anyhow. Still I will get this value. I can write like this also, root 3 into 3.3. No need to multiply 10 power 3. Still I will be getting this value, 500. 3.3 into root 3, you just check. So it was just an elaboration, 1.73 into 3.3. If I don't write also, no problem. Are you getting my point?
Yes, sir.
Huh?
Yes, sir.
If I don't write also, like if I directly take like what you are saying, kVA, okay, is equal to root 3, huh? V line I line, still I'll get the value like that, 500 root 3 into 3.3. Because naturally, if this value was given in kVA and this in other dimensions, so it would have created a problem. But in this, that's why if this is kVA, if this was given in other quantity, kilo was not there, because it's getting cancelled, so I'm getting the answer. That's why I elaborated this step a little bit. Got my point? Any
Yes, sir.
doubts?
No, sir.
Okay, so no doubt. So you have to ask whatever doubt you are having, you should ask me. Okay, so now see, one more important thing I want to, like, most of the students make a mistake. Okay, so when we write this power, okay, in terms of phase quantities, it is 3 V phase I phase. Okay, now you see one thing, when we write in terms of suppose the machine is connected in delta. Okay, in delta we know that our v phase is equal to v line. Okay, and our I phase in terms of delta would be equal to how much? I phase is, sorry, so here if we want to write this 3 v phase, okay, I phase, so it would be I phase would be equal to I line by root 3. So I phase is equal to I line by root 3. This is in case of delta. So now you see this 3 can be written as root 3 into root 3. This is 3 into v phase, sorry, in case of delta, v phase is equal to v line, so we'll write v line into I line by root 3. This gets cancelled. So the power in terms of line quantities this becomes root 3 v line I line in case of delta. Now let's take the case of star connection. In star connection, you have v phase is equal to v line by root 3. Okay, and I phase is equal to I line. Suppose you have to write for star connection, P is equal to, again we'll write root 3 into root 3. Okay, into v phase would be equal to v line by root 3, and I phase would be equal to I line. Most of you might be knowing, some of you have confusion. So this is, okay, root 3 v line I line. So we notice, despite the network being either delta connected or there are only two connections for three phase, either delta or star. So in both the cases, in terms of line, if we're writing, it is root 3 v line I line. In terms of phase, it would be, in terms of phase, it would be 3 v phase I phase. This is in terms of phase, and P is equal to root 3 v line I line whether delta or star connected, irrespective of this. Did you get my point? Yeah, Pratika? Pratika,
Yes, sir.
are you there? Hello? Yeah, Pratika?
Yes, sir.
So something clear happened? Like some confusion was there?
Yes, sir.
So this got corrected. Like this is very important. Sometimes you get like how power is like 3 v phase I phase, and suddenly it becomes root 3 v line I line. So in terms of line, if you're writing, it becomes root 3. In terms of phase, if you're writing, that is 3 v phase I phase. Nilanakshi,
Yes, sir.
did it clear a little bit?
Yes, sir, it's clear.
So you had some doubt or not, like that?
Yes, sir.
So these doubts are there because I'm teaching over the years. I've seen students are making these elementary doubts. So start learning basic very well. So if the basics are really very clear, now you are moving to the power system, other subjects and machines and all, you have to do this. And from where it comes, the three phase. I think you all people need. I will share one book. So you just go through this book. Okay, I'll put in my Charles Alexander Sadiko. This book is there. Charles Alexander Sadiko, wherein basics of electrical engineering is explained very well. Basics of electrical engineering. So this basics of electrical engineering has to be very good, and units and dimensions and another thing. So let me give you one question. Let's see. So you please do this question. Okay. Now find the main dimensions of a 100 MVA 11 kV, okay, 50 hertz, 150 rpm, three phase water wheel generator generator given BAV is equal to 0.65 Weber per meter square. Ampere conductor per meter is equal to 4,000. Okay, 40,000. Sorry, 40,000. The peripheral speed, the peripheral speed the peripheral speed should not exceed should not exceed 65 meter per second 65 meter per second at normal running at normal running in order to limit the runaway.
Sir,
Yeah, tell me.
so what
Yeah,
is written to three phase?
find the main dimensions of a 100 MVA, 11 kV, 500, 50 hertz, 150 RPM, three phase water wheel.
What are
This is
wheels?
water wheel I have written. Okay, water wheel. Normally, in order to limit the runaway speed. So assume kW is equal to 0.955. So this is your assignment. So tomorrow I'll randomly ask any one of you to explain me. So this is very simple question. So you can do this question on your own. Okay. So here one important clue I'll give you. So this is like, so you have to L by Z ratio is the peripheral speed is mentioned over here. So you can calculate the peripheral speed and another things. So you have a circular pole. See, you take the L by Z ratio. I'll give here 0.6. Okay, so you take the L by Z ratio to be around 0.65. You take. Okay, and then you try to do this problem. Okay, and so this is little you go through the books and another things. It has appeared again for 10 marks. See, in one examination, if you were doing this problem comes for 10 marks. Okay, in the same problem, see, in an question, I see in a V2 examination, first this question comes for 6 marks. Okay, then this another question comes for 10 marks, 16, and this comes for 10 marks. Now what I have written, so this is 26 marks. Hardly it will take 20 minutes to or 30 minutes to get 26 marks. Within 30 minutes, if you get 26 marks, so you can imagine if you do this part. So the other part, output equation, this thing, that thing, you can score aram say 80 to 90 marks. It can improve your percentage. This subject, na, this subject can improve your percentage significantly. It is very easy to score 80 to 90 marks in this subject. If you just go through the videos or the notes, whatever are there, or the previous year's question paper, in most of the subjects, nobody will fail in any subject. Only the basic concept should be clear. Okay. So the what I find is that the basic concept is not there most of the times, and you are very hesitant to do a problem, like you are waiting to be spoon fed. That is a wrong approach. So beforehand, you have to be there. You have to attack it, but in a controlled manner. You have to show controlled aggression, not like over aggression or overconfidence. You have to be confident and nervous at the same time in order to succeed. So it is already 3:40, so I'll just stop my class. And what I will like is that you people please give the attendance, so that yeah, you can give the attendance and you can